So for number 9, we have a piece of wire and it is 20 feet long. And we are being told that we want to cut that into 2 lengths. We don't know if those are going to be even or not. So we can just model it as one of those pieces is going to be x, which means that the other piece has to be 20 minus x, so that when these two are added together, it adds up to 20. Each one of these pieces needs to be made into a square. So if I have a perimeter of x, because that's the total length of wire that's going to go around my square, that's going to be equal to 4 times my sides, because there's 4 sides that we have to make for our square out of x feet of wire. That means we can define x over 4 as s. We also know that the area of a square is the sides squared. So area equals sides squared. We can substitute in x over 4 for side. Okay. On this piece, we're going to do something very similar. We know that the perimeter is 20 minus x, and we know that that has to equal 4s. To get s alone, we're going to divide everything by 4. So it cancels out on the right. 20 divided by 4 is 5, and we're just going to leave that as x over 4. And that equals our sides. Again, area of a square is side squared, so we can substitute in 5 minus x over 4 for sides. Now the question is asking us to maximize the area of both squares. So we have this square and this square. So when we have the 2 squares together, we're going to add those areas. Using appropriate tools strategically, we can find the vertex of the parabola modeled by this equation to find what the minimum area of the squares altogether would be for this situation, and that would help us figure out x. Once we know what x is, we know what this cut length is, and we can use it to find the second cut length.